Hey guys, today we're going to expand on what we talked about yesterday. Basically, what we did yesterday was we solved trig functions. So today we're going to find missing sides of trig functions. Okay, so it does say round to the nearest tenth. Again, make sure that your calculator is in degrees. Okay, so it says solving sides of a right triangle. We're going to solve for the side lengths. So solving sides of a right triangle. It does say solve for x and y and round to the nearest tenth. So let's think of what our word is. Remember, it's SOHCAHTOA, okay, with sine, cosine, and tangent as our trig functions. So we can use what we have, or which one of these based on what we have. Okay, so I'm going to zoom in a little bit right here. Okay, so for this first one, this is our angle of reference. Again, we have our opposite, hypotenuse, and our adjacent. Okay, this one only has x, so that's all we're going to solve for. So here we have opposite and hypotenuse, so we are going to use sine. So this is the sine of 38. Again, this is what we did yesterday, equals opposite over hypotenuse, so x over 15. When our number is in the denominator, all you do is you multiply each side by 15. Okay, so then you have 15 times the sine of 38, which is x. And we just go over to our calculator and do 15 times the sine of 38 and hit enter. Okay, so I'm just going to double check because it is in degree. So my answer for x is going to be 9.2. 9.2. For number 2, our reference angle is 56. Here's the opposite, adjacent, and hypotenuse. So what we have is we have the adjacent and the hypotenuse, which means we're going to use cosine. So cosine of 56 equals 21 over x. And remember, when we have our variable in the denominator, you switch that and the trig function. So you have x equals 21 divided by the cosine of 56. So let's go over to our calculators. 21 divided by the cosine of 56. And so this x value is 37.6. For number 3, we have x and y. Okay, so let's solve. If this is our point of reference, then we have our opposite, adjacent, and hypotenuse. If we solve for x first, then we need to use the side that has the number and x. So we're going to use sine of 24, which is opposite over hypotenuse. Again, our variable's in the denominator, so you just go ahead and switch. And then if we put this into our calculator, we have 14 divided by the sine of 24. And x equals 34.4. If we solve for y, what we're going to use, since we have adjacent and opposite, we're going to use the tangent. So this is the tangent of 24 equals opposite over adjacent. Okay, again, our variable's in the denominator, so you're going to switch. Okay, and if we go over to our calculator, we do 14 divided by the tangent of 24. So your y value is 31.4. Okay, this is what we did yesterday. I'm going to continue on to this problem here. Okay, I'm going to zoom out a little bit. It says, besides trig, what else can we always use on a right angle? Right, because this is a right triangle, but we are not given either of the other two angle measures. So if we do not have that point of reference, then we're going to use the Pythagorean theorem. Okay, we're going to use the Pythagorean theorem, which again is a squared plus b squared equals c squared. So, remember your two legs are a and b, with c being your hypotenuse. So you have x squared plus 12 squared equals 15 squared. Okay, so if we're going to find this, you would do 15 squared, which is 225. 12 squared, which is 144. Okay, then you're going to subtract 144, and that gives you 81. And the opposite of a square is a square root, so x is 9. So that missing side is 9. Okay, not every time if you're given this Pythagorean theorem problem, you're going to get whole numbers. You're allowed to have decimals as well. Okay, so again, we do not have an angle measure, so we're just going to use Pythagorean theorem. 24 squared plus 20 squared equals x squared, because x is across from the right angle, which means it's the hypotenuse. Okay, 24 squared is 576. 20 squared is 400. These added together is 976. And taking the square root of both sides, so second x squared, excuse me, of 976 is 31.2. Remember, you use Pythagorean theorem. We are not given the other two angles besides the right. Okay, going back to what we have been doing, this does give you a point of reference. Okay, so this is your opposite, adjacent, and hypotenuse. To find x, we have opposite and hypotenuse, so we're going to use the sine of 65 equals your opposite over hypotenuse. Because our number is in the denominator, you just multiply both sides by 24. Okay, so you have 24 times the sine of 65. So 24 times the sine of 65. And this is 21.8. Okay, you have to round. 21.8. To find y, you have adjacent and hypotenuse, so you're going to use cosine of 65 equals your adjacent over your hypotenuse. Again, you have your number in the denominator, so you just multiply each side by that. So you have 24 times the cosine of 65 equals y. So 24 times the cosine of 65, and y is 10.1. Now, this triangle looks completely different. Okay, now, these dash marks, remember, makes it an isosceles triangle. Okay, so I want to know what this side is. Now, you could always, if you are given a triangle like this, drop down in altitude. Okay, and this is now two equal parts. Okay, so let's find this side first, and then since they're the same, we'll double it. So, given this as our reference point, 58, you have adjacent and you have hypotenuse. So we're going to use cosine. So cosine of 58 equals your adjacent over your hypotenuse. Multiply each side by 18. So you have 18 times the cosine of 58 equals y. Okay, so let's figure out what that is. 18 times the cosine of 58. So one segment of that bottom is 9.5. Okay, but because there's two, you have to do 9.5 times 2, which gives you x. Okay, so this would be x equals 19.0. Do you want to say hi?
Yeah. Hi.
All right. She's been waiting to say hello. All right. So this is one of those triangles that we have multiple in.
I want to say hello.
You just did.
Hello.
This is a triangle that we have multiples in. So we do have 2 right triangles. So I'm going to show you. We're going to look at this one. Okay, to get x. And then we're going to look at another one. I'm going to add y here. Okay, so we're going to find y with that one. So, looking at this yellow triangle first, let's ignore the 68 and the 26. I lied. We're going to look at the small one first. I'm sorry. We're going to look at this one first because we need to get y in order to solve for x. My apologies. So let's look at the blue first. So y is your opposite. This is your hypotenuse. So we're going to do sine of 68 equals opposite over hypotenuse. Okay? Again, we have to use the small triangle. We had to add a y, right? Because we need a piece of the big yellow triangle to solve for x. Okay, so that's why we're doing this one. So we have to multiply each side by 26. So we have 26 times the sine of 68, which that one side is going to equal 24.1. Okay, so this side here is now 24.1, which we can then say, looking at this yellow triangle, you have the opposite side and the hypotenuse. So again, we're going to use sine. So sine of now 22, right? Because we have to use this reference angle. This one's now gone. Okay, sine of 22 equals 24.1 over x. So because your x is in the denominator, you're going to switch. X equals 24.1 divided by the sine of 22. So onto our calculators, 24.1 divided by the sine of 22. Your x value is 64.3. Okay, there's some problems on the back. If you would like to give them a try, you may. Otherwise, your homework is numbers 98 through 115. Okay, I will be back tomorrow, so I'll check homework Wednesday. So I'll check the last couple days because I have not checked those. And yeah, I'll be back tomorrow.